So what you're doing is you're solving for some different quantities with the equation that says percent yield equals the actual yield divided by the theoretical yield times 100. And again, your actual yield is going to have to be less because of conservation of mass. Okay? So theoretical yield is the maximum amount that you can produce in a reaction, and the actual yield is actually how much you do produce in a reaction. So then you go ahead and percent yield is actual yield divided by theoretical yield times 100 to get your percent. So the first one, what's the percentage? 75%. Right. So when you do problem 28A on page 322, you would take the 20 grams, dividing it into the 15 grams times 100, and you get 75% yield. Okay, the next one, you've got a 48% yield. They tell you what it is. So you're not solving for percent yield. You have a theoretical yield of 3.45 grams on letter D. So then you basically have 48% equals X grams of actual yield over 3.45 grams times 100. So then you have to solve for the X grams. Okay? So it's going to be about 50%. So your original number of the theoretical yield is 3.45 grams. It's going to be about 50% of that weight for your answer. Okay. So up above here we have the work for the second one, part D. 48% equals actual over 3.45 grams times 100. We get rid of the percent. When we do that, we multiply both sides by 3.45 grams. So that will make it multiplied by 0.48, and you get 1.66 grams as your answer. Okay? So, questions on that? Here's the setup. We're solving for actual yield. We're taking the 3.45 and then canceling it out on the equation side. We're multiplying it by the 0.48, and then that gives us our number of grams, 1.66 grams. Okay? All right, so what we need to do now is connect two ideas. You guys will need to connect two ideas to understand this today. So the one idea is that we're probably going to have to do some of those mass-to-mass problems in which to do and solve the problem, okay? Because they're not going to be where they're going to give you the theoretical yield, okay? And they're not going to give you the percent yield sometimes. So what you're going to have to do is actually go through and work through a reaction. And we're going to look at number 29 on page 322. So look at 29 on page 322 and write out that equation if you would. Number 29 on page 322. Write out PCl3 plus PCl2 gives you PCl5. Write that out. Okay, up above I have the equation written down. So we need to talk a little bit about what the equation is, what the word problem is, and how it's connected to solving the problem. Okay? Alright. What they say is that in the problem, they want to know how much should be produced in this reaction. What do we know about the reaction? Well, we know it's 83.2% efficient. It means it can only make 83.2%. So we know that. We also know that of the reactant, that we have 73.7 grams of PCl free. So up here on the board, above PCl3, I have how much reactant I start out with. So if I take the 73.7 grams and go through the whole process of solving for grams of PCl5, what is this going to be? Is this going to be an actual yield or a theoretical yield, this value? What is this going to be? I take the 73.7 grams and see how much I can produce, maximum yield, and I come up with that number. What is that yield called? Is it theoretical or actual?
Theoretical.
It's theoretical. Okay, so that gives me a theoretical. Now, this equation I had originally written out is wrong. What should it be written out as? Actual over theoretical. So disregard what I have written up here. It should be actual over theoretical. Okay? So, we can calculate the theoretical. So we can solve for the theoretical. Alright? They want to know how much is actually produced. So you're going to have to solve for actual. So you know the percent. You know you can find a theoretical that allows you to solve for actual. So go ahead and do a mass to mass to PCl5. I've given you the molar masses down below that you can use to get there. So you don't have to do the calculations for molar weights. So go ahead and see how much, in theory, you can produce a PCl5. Okay?
How much do you want us to round it?
Well, guys, rounding you should be something that you should be able to tell by the original measurement. So it was 73.7, which is 3 digits. I should have 3 digits in my answer. So, questions on the setup. Change grams to moles of PCl3, then do your mole to mole, which is 1 to 1. Some of the students are always just putting 1 to 1. Every time they do this ratio, they're putting 1 to 1. No matter what the numbers are in front, they're always putting 1 to 1. You can't get into that habit. This one's a 1 to 1 because that's what the ratio is. Okay, so we have 112 grams of PCl5. That is the theoretical. Okay? The percentage is 80 that you can make is said to be 83.2%. So you have 83.2% equals X grams of actual over 112. So now go ahead and set up and solve for your actual. It's just like the last one we did on D. Or on, letter D. Be the same setup. Okay, so go ahead and do that and see what you get out for an actual yield. Okay, so we have 112 grams of PCl5. That's the theoretical yield. That will go up in our equation for theoretical yield. The actual yield we're trying to find, which is X. So then what we do is divide both sides by 100. So then we end up with 0.832 equals X grams over 112. Then we can go ahead and multiply 112 times 0.832, and that gives our actual yield. So our actual yield is 93.2. So you would take the 112 grams of theoretical yield, plug it in your equation, eventually multiply it by 0.832, and then by doing that you get the actual yield, which is 93.2. So the questions that you need to do on the assignment would be page 893, and that would be problems 218A and B, 219 all of it, and 225 all. So, and those are on page 839.